America was the kind of the birthplace of nuclear, right? Where it all kind of actually happened where we're building our first reactor, which is going to be kind of like what we call the birth of the second atomic age. But the first atomic age at Idaho National Lab in Idaho, obviously in the US, they built 52 test reactors in a matter of just a few decades. And the learnings from that are largely what propagated around the US and then the world, to cause all these different types of reactors to get explored and deployed and so on. That's largely what we have to thank for like the 400 some reactors that are around the world today, powering these cities and so on. Nuclear is super misunderstood. I think it's probably the most misunderstood underdog technology I've ever seen in my life. I think it has insane potential to do so much good for humanity. And it's just crazy that we're not investing more into it. So I think that's changing. But right now, China and even Russia are ahead of us.
Hey, everyone. Welcome to Founders in Arms podcast with me, Imad Akan, co-founder and CEO of Mercury.
And I'm Raj Suri, co-founder of Lima and Tribe. And today we have Matt Loszak, co-founder and CEO of Aalo Atomics. Welcome, Matt.
Awesome. Thanks so much for having me.
We actually had Matt's now co-founder on the podcast about a year ago. At that time, they were not working together. So it's cool to have Matt to see the Yasser Arafat.
Oh, right. I didn't know they were working together.
That's right, yeah.
Yes. Yasser was a cool guy. He was working at one of the labs, right? One of the national labs?
Idaho National
That's right, Idaho National Lab. That's right.
But you guys have made a ton of progress in just a year. I guess you basically started less than a year ago, I think. Give us a quick rundown on, I guess, like what you're doing and the progress so far.
So 18 months ago, the company was still just Yasser and me. And then around 7 months ago, we were around 10 people in a WeWork. And in the past 7 months, we moved into this 40,000 square foot factory space, built out the pilot factory line, and finished the full-scale non-nuclear reactor prototype. So it's been a bit of a whirlwind. It's been pretty exciting. We are now about 50 people, 50.
Matt, you didn't even say what you're working on. You're working on a small modular reactor, right?
Yeah, so we're making factory mass manufactured nuclear power plants.
Yeah. What kind of technology?
So it's a liquid metal cooled reactor with off-the-shelf uranium dioxide fuel. So it's the product itself is a 50 megawatt nuclear reactor power plant that's meant for powering AI data centers.
How many houses does like 50 megawatts do? Like it's hard to
This would be like 50,000 US homes on average.
I guess I think from a non-expert perspective, it seems like there's a lot of kind of small modular reactor companies and technologies. Like, how do you think about the whole landscape? How many people are like as far along as you? Give us like a quick kind of landscape overview.
Yeah, there's definitely quite a few companies in nuclear, especially in the past 3 or 4 years. A lot of new ones have started up. I think if you, first of all, take a step back and ask yourself why that is, there's kind of been this groundswell in support across all these different dimensions. So, public support for nuclear is at all-time highs, investor support, government support, and probably most importantly, customer support, actually having, customers like these hyperscalers who want possibly like 30 or 40 gigawatts worth of these small nuclear reactors to power their data centers. All this is kind of aligning, and that's kind of, I think, why you see a lot of new companies getting started. But then there's also a good number that have been around for 5, 10, 15 years. And, part of that is that there was a challenging time in the early kind of 2010s after Fukushima, where nuclear fell out of favor for a bit. It was harder to make rapid progress. But at a high level, you've got different types of nuclear companies. You've got some going after data centers, some going after remote diesel, some going with much larger plants, some going with much smaller plants. There's kind of a lot of competing kind of different ideas and concepts for what the best solution is here. But what we believe at Aalo is there's kind of this economic sweet spot somewhere between 10 and 100 megawatts on a reactor basis, where you're going to get this kind of nice balance between economy of numbers and economy of scale. And, what we've seen is that even though we've been building a lot of gigawatt scale nuclear plants in the West, that's not necessarily the optimal way to do it. And we're kind of seeing this because there's actually 8 utilities that have approved licenses to build these large plants, and they're choosing not to. So it's not really like there's some kind of regulatory blocker here or something. And the reason they're choosing not to is actually because of a fear of cost and schedule overrun, because we've just lost the muscle of building these large plants in the West. And so the answer, we think...
I thought it is like even in the development phase, I mean, you say they've got approval, but even the development phase is like the reason it's slow is because of regulatory issues, right? Or you're saying like, hey, it's just like we just don't know how to build these things fast anymore.
It's really more the latter. I mean, yes, the regulator could be more efficient. That's definitely true. There's room for improvement there. And that's a big part of why we've been taking kind of a two-pronged, like parallel regulatory path approach. So at Aalo, one more thing that makes us unique, I'll try to answer your question by interweaving these kind of different factoids throughout the whole thing. It's a deep topic. But we're doing DOE authorization for our first plant, not NRC for the first one. And so that's another kind of factor there is our team.
Like that means you're selling to the government directly? Is that what that means? Or what does it mean?
No. So it just means we're building on non-civilian soil. That's kind of the distinction for DOE versus NRC. So if you're doing like a government lab or a military site, you can do DOE authorization, and civilian is NRC.
And DOE is faster?
Yeah, DOE is faster. Yeah, the key thing that I was going to say before is just around, this whole idea of a mass manufacturing smaller reactors being better than doing kind of bespoke one-off large reactors. This is not really a consensus view. Like some people in the industry think that it's better to do these large reactors. And really the reality is like this has never been done before, like a factory to mass produce nuclear reactors. And, our whole thesis on why it's not been done before is because we think there hasn't been the right type of customer. Right. So if you think about, the demand in the past 70 years, it's been a city here, a city there, maybe a one-off, gigawatt scale plant. But right now, like these data centers, they have the demand equivalent of 30 to 40 new cities within like a 5 or 10 year time frame. And so that's the one thing is the level of demand. 2 is that they also have this really high willingness to pay because these electrons are more valuable to them. So that's like this amazing killer combo to help actually get this factory set up, because then you can come down the cost curve as you do the first of a kind to nth of a kind. And once you get it set up, you can then go after so many other markets, because data centers are only 1% of power globally, 4% in the US. And there's just so much else to go after once you get the factory set up and kind of prove the predictability on cost and timeline.
I guess, you've been pitching some VCs recently. I think you raised I don't know what's public or not, so maybe you can say what your most recent raise was. But when you're pitching, like, if everything goes right, like, what do you say in terms of like how many of these will be deployed in the next, 5 years or 10 years?
Yeah, I mean, so we did the 6 million seed in year 1, the 30 million Series A in year 2. Right now, just between you and me, we're aiming to raise this 100 million, which we're getting close on. So that's what's going on right now.
I mean, you're on a podcast right now, so it's not just between you and me.
Yeah, that was a little tongue in cheek. Yeah, but so we the goal here is to kind of flip this on its head, where traditionally it takes 10 years to build a gigawatt power plant. We want to build one day 10 gigawatts per year. So, we imagine having several kind of gigawatt scale factories that can produce a gigawatt per year in each factory through making these smaller reactors. So that's really the scale that's needed to meet the demand.
How small are we talking about?
Each reactor is around the size of like a pickup truck. So you can picture 5 of those fitting in like a footprint that's on the order of like 20,000 square feet, including the turbine and the operators and that kind of thing. So
I could have one in my garage.
You could have a reactor in your garage. We won't we won't put it there for you, but you could buy one and put it there yourself if you want. But that's the idea. So it's this footprint that's like 20 or 30% of the equivalent footprint of a data center. So it's quite compact. And, part of the value for these data centers is it's a very high level of availability. So when you have 5 reactors instead of one big one, if any one of those reactors is down for refueling or maintenance, the rest can make up the delta. And so that's a big part of the value prop for these data centers. And the second one is speed, the time to power. So you can then deploy these much faster when you're making a lot of it in parallel in the factory instead of doing it kind of in a bespoke way on site.
What are some of the downsides of your approach? Like what would a detractor, one of the big manufacturers of these big, large reactors, what would they say about you guys?
Yeah, I mean, the big thing for us is like the impetus is on us to prove this on the economic side, because, a lot of people would say that reactors went larger for a reason. When you go larger, you get better steam turbine efficiencies, you get better neutron efficiencies, bigger pipe diameters. Like a lot of things work in your favor when you go larger. But the challenge is just, it's harder to mass manufacture a much larger design. And so there is this kind of sweet spot, we think, where, you get the most power possible out of something that still can be shipped on everyday roads, that's not too wide or too long from like a reactor vessel perspective or all the other modules that make up the plant. So that's the kind of balance or trade-off we're trying to fit, is what is the most powerful thing that can make the most revenue out of something that can be in these modules that fit on everyday roads.
What about safety issues? Like, I remember talking to Yasser about this. Do you have any safety advantages? Like, and these are going to be presumably more closer to like, human dwellings. Is that right? Because I think that was the plan.
Yeah. So initially, a lot of these data centers are not like literally in your backyard. They're kind of a little bit further out in industrial areas. But yeah, the whole idea here is if you make thousands of reactors in a factory, you should want it to be very inherently safe. The first thing I want to highlight is like, nuclear is already very safe. It's as safe as solar and wind statistically. So we don't have to really beat that safety record. It's already as safe as it can get. But the question is kind of, can you, make it more inherently safe, maybe do it in a more simple way, achieve that same level of safety in a more simple way. And then the other thing you can do is kind of change your design so that if there are issues or things that go wrong, make sure that they happen on the non-nuclear side of the system. So, for us, we have a lot of our radioactive stuff in the core, which is in this big kind of pool, this vat of sodium, liquid metal. And then if you look at the history of sodium reactors, any kind of issues that came up were more on the secondary side, which was outside of that kind of nuclear vessel. So that's one big thing that can be done. Two is also, when you use the liquid metal as a coolant, you get a really high thermal conductivity. So, for the same reason, when you touch a metal, it feels cold, not because it actually is cold, but because it's taking the heat away very quickly. So liquid metal is a great coolant for that reason. And what this means is you can avoid something like Fukushima, where you need backup power to keep your reactor cool in a shutdown scenario. So in this situation, the natural convection of that liquid metal is actually sufficient to take the heat away in a shutdown scenario, and you don't need backup power to keep it cool in that kind of situation. So there's things like that. And one other really cool thing I just want to highlight is, a lot of people don't realize there's actually around 25 schools around the country that they have nuclear reactors on campus. And people walk around, they don't know that there's a nuclear reactor there. And the reason that's okay is because it uses this special fuel called uranium zirconium hydride, which we are not using. We've moved away from that, but I just want to highlight as one cool safety example. This is a special fuel that's basically impossible to melt down. So the hotter it gets, the less reactive it gets. And they allow students to go in and pull the control rods out as fast as they can. They pneumatically eject them. And the control rods are usually the brakes. That's the thing that slows the reaction. And what happens is this will pulse from a megawatt to a gigawatt in a millisecond, and then it'll shut itself off safely due to the inherent safety. And what's really interesting is the person who invented that fuel, the most safe nuclear fuel in the world, was also the inventor of the world's most dangerous weapon, the fusion bomb. So Edward Teller. So cool little factoid. These scientists, they didn't want to be working on the weapon. They wanted to be making clean, safe energy. But in the 50s, 40s, they got drawn away, obviously. But anyway, lots of cool safety tactics for nuclear.
Yeah, he was in that movie, Oppenheimer, I remember. I looked him up on Wikipedia after, yeah.
Ideally, they would have called the nuclear weapon something else, nuclear energy something else, because I feel like the weapon gives bad branding to the energy side of the equation.
Yeah.
Gotta think of a rename.
It's too late, Imad. You can't change the branding. This is Imad's big idea.
Well, maybe Aalo will become so big, so people just call it Aalo from now on. It's like the brand.
Yeah, the Kleenex of nuclear. Or maybe we need a better one than that.
Yeah. Apart from, I guess, AI as a tailwind, have you also found that the government is also kind of pushing nuclear? I mean, I feel like the government needs to be behind it for it to really work at scale.
Yeah, definitely. I mean, we've seen some things, for example, after Trump took power, a lot of people we interfaced with the DOE were saying, this is now a no BS environment. We're going to be getting through everything much more efficiently and more streamlined. So psychologically, it seems to have some effect. More specifically, there was a recent RFI that came out, which was still kind of tied to data centers in an interesting way. So there's this kind of national effort here to not lose to China and Russia on AI and nuclear. And what this RFI was all about is the idea of possibly deploying a lot of co-located nuclear plants and data centers on non-civilian soil. And when this came out, we kind of almost rubbed our eyes in disbelief because, to our knowledge, we're the only company doing DOE authorization for a plant that can produce power. And this is possibly the authorization approach that can be taken for many gigawatts of data centers and nuclear plants around the country on non-civilian soil.
You're saying this RFI came from the government?
Yeah, from Trump and Secretary Wright, yeah.
I feel like there's been a ton of development by China in nuclear. They have a new thorium reactor. I think that they have a big plan to get hundreds of nuclear power plants. Is America definitively behind her, or is that kind of PR?
Yes. We definitely are. I mean, America was the kind of the birthplace of nuclear, right? Where it all kind of actually happened where we're building our first reactor, which is going to be kind of like what we call the birth of the second atomic age. But the first atomic age at Idaho National Lab in Idaho, obviously in the US, they built 52 test reactors in a matter of just a few decades. And the learnings from that are largely what propagated around the US and then the world, to cause all these different types of reactors to get explored and deployed and so on. That's largely what we have to thank for the 400 some reactors that are around the world today, powering these cities and so on. But yeah, right now, China is ahead, and I'm not going to name names, but there's one company who I know China's building basically almost verbatim their design. And, they were texting in the engineers saying, hey, look, this actually worked out. This kind of texting behind the scenes on these different teams on the engineers who want to collaborate across countries. But, it's happening. And I think it's really important that we don't lose on this front because, nuclear is super misunderstood. I think it's probably the most misunderstood underdog technology I've ever seen in my life. I think it has insane potential to do so much good for humanity. And it's just crazy that we're not investing more into it. So I think that's changing. But right now, China and even Russia are ahead of us.
Russia? Russia's ahead in what sense?
Russia's ahead on nuclear, for example, in a few different ways. So one thing you might have heard of is HALEU, which is high enrichment fuel. It's kind of 20%, high assay, low enriched uranium. So a lot of nuclear companies in the US had HALEU in their pitch decks from 2005 until 2022. But then Russia invaded Ukraine, and the US decided it can no longer buy HALEU from the the U.S. can no longer buy HALEU from Russia. So our supply chain for HALEU is completely atrophied without Russia on this front. So that's one way they're ahead. Another way is they've been building quite a few different plants in different kind of situations, different types of plants. They've done a lot more progress on certain advanced reactor types. Not sure how much detail to get into right now, but it's impressive. Yeah.
I'm sure we all saw Oppenheimer, and we saw the kind of effort that went into. Was that the dawn of the second atomic age? Was that what you call it in the 40s, or the first atomic age?
That was the first one. Yeah.
That was the first atomic age.
This could be the dawn of the second one.
Oh, you said this can be the dawn. So we're entering the dawn of the second atomic age. What sort of like infrastructure has been created, or organization has been created to make this happen? Is it a bunch of entrepreneurs like yourself and Yasser, or is there like a real, is there a thousand flowers blooming at this point, as well as a government push?
I think there's a lot of good momentum right now. So at Idaho National Lab, they have this timeline chart that shows all these different initiatives that are happening in different circumstances. So one really cool one is EBR-2, which is this famous sodium-cooled reactor from the 60s and 70s. They've emptied that out and repurposed that containment dome. It's like this famous silver dome to be this test bed for a couple of new kind of test reactors that are being built. So that's happening. There's Marvel happening, which is the program that my co-founder, our CTO, started at Idaho National Lab. There's Project Pele, which is a high-temperature gas reactor that's really well-purposed for military applications. So there's a bunch of these interesting kind of new projects spinning up that all have different potential in terms of their use case and their size and their kind of flavor and so on. But I think we need a lot more to achieve all these goals that we're setting out. Like, if you think about the workforce right now, it's about 100,000 people in nuclear in the US. We probably have to triple that to achieve these goals we're laying out. So the momentum is there from like a funding and customer support and government support kind of perspective, but there's still a lot of change that has to happen. A lot more people have to get involved to meet the demand we have in front of us.
It's kind of interesting that you say you have to triple the workforce. Obviously, actually, maybe there are lots of people going through like a bachelor's degree in nuclear engineering, but I assume not. You came from a software entrepreneur background, so do you think anyone can become a nuclear engineer or start working on these things? How do you think about new people entering the space? And how did you enter the space?
Yeah, I mean, I think we're going to have to hire from a lot of different places in order to meet this demand. So, what's fortunate is that with companies like SpaceX and Tesla, they kind of, I think of it almost like the 4-minute mile. Like, it shows what's really possible in terms of rapidly setting up factories to mass produce certain large hardware. And, for example, in rocketry, there's a lot of good examples for us of, rolling plates and welding and lots of good learnings that come from that industry, dealing with high temperatures and things like that, that we can pull from and hire from. So, we don't need everyone on Earth to instantly become a nuclear engineer. That's a pretty niche aspect of this. But, there's a lot of different sides of the nuclear business that need help. So I think there's tons of people from lots of different walks of life who could easily enter this workforce. And that's what we're seeing. And we need a lot more of it. One other funny comment is it's kind of like a camel's, humpback kind of distribution right now in terms of the age distribution in nuclear. So there's a lot of people from the first atomic age who you can hire from that are maybe in their 50s, 60s, and 70s. And then a bunch of people in their 20s who are getting really into it. And a lot of people in between or I should say a lack of people in between, because it kind of, nuclear fell a little bit out of favor for a few decades there. But yeah, in terms of my story, how much detail should I give? I mean, I could rant on this for a long time.
I mean, I'm definitely interested in I guess what Mercury does is pretty hard, but what you're doing is way harder, right? Why not take the easy path and go do another software startup? Why take this kind of hard path?
Right. Well, my whole life, I always wanted to do something that kind of combined my learnings in software and business with science and engineering where I came from. And nuclear was always in the back of my mind. So, when I was growing up, I had pretty bad breathing problems. I had asthma. The air quality in Ontario was pretty bad because we had a lot of coal plants. But then fortunately, the government decided to turn those off and go all in on nuclear. And lo and behold, the smog days per year went down to 0 and my asthma went away. So I thought, my God, this technology is pretty incredible. And that's the kind of thing that partially drove me to study engineering and physics and take courses on nuclear. But then, at the time when I graduated, Fukushima had happened a year ago. And I was thinking, maybe this is a kind of a hard time to start a company like that. So I did 10 years of software companies. And as you know, most recently started Hume in 2016. And we recently sold it, had a good exit there. But I actually left 6 years in after building Hume into like a 150 person company because one of the things that tipped me over the edge was I watched this movie called Radioactive, which is about Marie Curie and the discovery of radiation. And it got pretty bad reviews, but don't let that stop you from watching it. Because when I was watching it, I honestly kind of teared up and I was like, this is meaningful, helping to push humanity forward with science. And I really wanted to be doing that. That's really all my life what I've been trying to get towards. So yeah, I decided to leave a little bit early after our Series B at my last company, Hume, and explore how to start a company like Aalo. And took maybe 6 months of exploration into different areas, and then got married to nuclear and met Yasser, about 100 people into the networking of that list. And we kind of immediately hit it off. We knew that we had very complementary skill sets, very similar values and vision for what nuclear should become. Similar sense of humor, which is important because I think I spend more time with him than he does with his wife. So it's you got to make sure you get along, as you guys know. But yeah, that's how I got into this stuff.
It's cool. Where are you from in Ontario? I'm from Toronto.
Oh, cool. Yeah, Toronto for me as well.
Whereabouts?
Around Yonge and St. Clair. Yeah.
Oh, downtown. Okay. Cool, man. Yeah. Nuclear is a big deal in Ontario. I actually worked for Ontario Power Generation in one of my work terms, and I went on a tour of the nuclear facilities in southern Ontario. I don't know if you still remember the names. I probably remember the ones that I went to, but it was cool to actually go inside a nuclear power plant.
Darlington, Pickering.
Darlington was probably the one, yeah. And Imad, have you been to a nuclear power plant?
No, I wish I had. Can you just go to Diablo or something and go do a tour?
You probably have to have a little bit of an in, but I think it's not too hard to find for someone like you.
Oh, maybe I'll come visit you, man. I was really disappointed by Oppenheimer. I feel like it was so focused on the negative side of nuclear, and I feel like they kind of... Yeah, I don't know. Is that not true in radioactive? Like, did they actually focus on a little bit more? Like, I feel like this is like such a powerful technology, and we should be like not just focusing on like, oh yes, you can like kill people with it.
Oh man, I totally agree. I mean, Oppenheimer was cool. It was a well done movie, but like, I think what it didn't highlight enough is like all the engineers and scientists who were working on this stuff. They didn't want to be killing people. That's not what they wanted to be doing, right? They wanted to be working on the energy source because they knew when they discovered this, they're like, oh my God, like this is, 2 million times more energy dense than oil and gas. This could be powering humanity for billions of years instead of just 100, maybe a couple more 100 years of oil and gas, which is like these dead plants and animals under the surface of the earth. It's like, it's such a no-brainer to use nuclear. And but then obviously the military complex and governments and the powers that be push them towards this other application first. And I think you're right. Like we need this kind of course correction in public perception because a nuclear reactor and a nuclear bomb are totally different things.
I mean, this is also my like general complaint against the media. Like, there's never an optimistic take on technology and science. Like it's always this like worst case scenario, and it's. I feel like we could inspire people. You disagree?
I disagree. I thought the movie did a really good job of like portraying the ambivalence of the scientists. scientists, of the work they were doing. I mean, in fact, at the end of the movie, this guy is talking to Einstein, right? Oppenheimer is talking to Einstein, and they show that he's shocked by what he said, right? And they're like, and like the bad guy in the movie, Robert Downey Jr., was like, oh, he was like conspiring against me, but actually he was shocked about the impact of the technology he was building. And
you're right.
Yeah.
I think you're absolutely right. Actually, it did display them as being conflicted, but I think maybe what's missing is it should have taken it further. What I'd love to see is like a 2.0 where it tracks the progress of all the scientists who then went on to make the energy sources and show just how amazing it is. Because we have like Inconvenient Truth, which never even mentioned nuclear, and we have like all these other kind of pro movements on maybe renewables, for example. But everything with nuclear is like, the Chernobyl series on HBO or some 3 Mile Island documentary on Netflix that has scary music and paints it as if it's like the worst industrial accident of all time. In reality, nobody died. So it's this crazy thing. And the last thing I want to make sure I said is, on this topic is, people don't realize that the bomb and the energy source, these are very different things. A nuclear weapon is like a stick of TNT. A nuclear reactor is like a stick of incense. It's a different thing, that one is not the same as the other. So the public, I think, will realize that.
Matt, you can change this, man. You got to make it like an Apple type of marketing, for nuclear. You got to do like product launches on stage like Steve Jobs, and talk about like the miraculous nature of nuclear. I think you could do it. I think you got it.
Exactly. Yeah, we're working towards that.
Yeah. Get some celeb endorsements.
Yeah, celeb endorsements, yeah.
So Matt, if you were talking to an entrepreneur that's like similar to you, kind of came from software, is thinking about kind of doing something big in either nuclear or some other hard tech field, what would you advise them? Or what, like, things that you think you did right, and like potential like mistakes you made as you were like making this kind of change in your career?
Yeah. Well, so I did spend 6 months basically making sure that I wanted to get married to nuclear. So I did some deep dives in biotech and AI and robotics, and spoke to some pretty cool people that have given TED Talks or like top researchers on those different domains. And I think like one thing that I kind of realized is it helped having the background in engineering and physics. That's what kind of gave me this bit more of a leg up on the kind of clean tech and nuclear side of things. When I was deep diving into biotech, I had to text my doctor friends being like, is this BS or is this promising? And, had more intuition. So I think having some degree of background interest in something in history and something is a huge leg up. But then obviously, I'd been out of the nuclear space for a long time and had a lot of catching up to do. And so I think like one thing that I would highlight after that explorative journey I went on is you can very quickly actually gain value to bring to other experts in a field before you even are an expert yourself, just by acting as this kind of connective tissue between all these experts. So, what I did is I would wake up and just have a ton of meetings with different people in nuclear. I would just ask a lot of questions. And then, initially I was basically, people were generous with their time. I had nothing to offer them, but very quickly I had this kind of narrative that was building, and I could run ideas off of people and cross compare notes and start to actually provide value to the nuclear ecosystem. And then I think that just builds and builds. So, I mean, maybe the advice...
Were you just like cold emailing them, or like how were you even getting to them?
Yeah, pretty much. Yeah. At the start, it was pure cold emailing. And I guess this was like 3 or 4 years ago now. So it's been like almost the equivalent of like a full university program, except it's been like, 24/7. So maybe a bit more than that.
And you were reading like the research papers and everything to like find interesting people to talk to?
Reading papers, reading books, watching interviews, and then talking to experts. And, and then like, I think that the whole thing was like trying to figure out what are the core problems that really need solving versus what are not problems, and going from there.
How did you think about the kind of fundraising aspect of this? Is it the same investors? Is it the same kind of thing that you did at Hume, or is it just a completely different world?
For the seed round, we did have a lot of the investors who put in money into Hume. They did participate in Aalo, and then also for the Series A and now the B, it's kind of becoming more and more focused. So people that are increasingly becoming energy-centric, nuclear-centric, but more so energy because there's not even that many nuclear-centric investors. And then, over time, we're going to have to kind of taper off of VC, involve more debt. Obviously, as our plants get built, we'll have kind of the holdco and then project cos with different types of financing for the projects versus the holdco. That'll be interesting.
I was at an event a few weeks ago and I met Chris Sacca, and I'm sure you know this, but he's got a fund that's just focused on fusion. Like he's made, I haven't found one investment to make in fusion, but he's got a whole fund, which I was like very impressed by. I guess where do you think fusion's going to be? Like, is this just like way further out compared to kind of the small modular reactors that you guys are doing?
Yeah, I mean, I always find it a little frustrating when I meet investors who are only investing in fusion and not fission, because I think like what that kind of does subconsciously is it places this kind of, weird reason in the back of people's minds, like, well, why are they not investing in fission? Like, is there some reason that fusion is better? And I think the funny thing is, like, fission is already available today, and it already offers basically all the value prop of what fusion would stand to offer, kind of thing. So, it's basically like the investors that I've spoken to, a lot of them know that or agree with that, but they're kind of making a bet that it's going to be easier to recreate the conditions of the sun in a box than it will be to convince the public that fission is actually pretty great. They're making a bet against human public perception, not really technology. That's the interesting thing.
You think there is no major benefit to fusion? I kind of always assume that like a fusion power plant can just produce like a ton more energy or something.
Yeah, so the narrative there is around safety, and we already kind of spoke about how there's a perception of nuclear fission not being safe, when in reality, statistically, it is as safe as solar and wind. So how can you get safer than that, right? And then 2 is around fuel supply chain. So in terms of how long will the fuel last us? And fusion is pretty cool because you could actually power humanity for many billions of years. But the same is true of fission. So if you do breeding reactors where you can use higher enrichment to do breeding, basically, you can extend the lifetime of all fissile and fertile material on Earth to 4 billion years. People don't often realize there's actually a lot of uranium in seawater. You could be mining it from there as well. And so,
there's also all of these thorium deposits, right? Which is like apparently also like billions.
Yeah, great. Yeah, exactly.
Is that just more kind of fuel density in fusion?
Yeah, so I mean, there is a bit of an energy density improvement where, nuclear in general is like 2 million times more dense than oil and gas, and fusion is like 2 to 4 times more energy dense than fission. So it's not really like many, many orders of magnitude. It's a little bit, but I'd rather take a technology that's available today because we have so many pressing issues to solve than hope that in decades this will be available. And one last thing is like, with fusion, first they have to get to net positive as a system, and that's going to be some major challenges. But then there's nothing about that says it should be cheap from first principles. In fact, it kind of sounds like it would be more expensive because you have all these materials challenges. In fission, the neutrons are the good guys. The neutrons go and they cause more fissions. They get absorbed in the other uranium atoms, and they cause more fissions. In fusion, the neutrons are the bad guys because they're not causing the energy to be released. They're higher energy particles that are going to go and basically destroy the whole apparatus that's producing the fusion. And so this is this thing called the first wall problem in fusion. It's a challenging thing that has to be resolved. And economically, it's a challenge because if you have to replace your machinery very often because of this higher amount of damage, that's going to harm your economics. So these are all probably solvable challenges. I'm just saying it's not a home run. And so if I was an investor, I'd be allocating capital in both, one that's available today and one that maybe can have some cool, niche uses in the future.
I mean, I guess you don't want to say it, but it sounds like fusion's dumb. It sounds like fusion's just way better.
I mean, I don't know. I like science research, and I think this, I'm all for money going towards it. And I think there's a lot of cool stuff that it can be used for. But I think if we're trying to solve problems today, then we need a lot more money to go to fission. And here's the thing. So far, a lot more money's gone to fusion. I think that's a mistake on humanity's and capital allocators' parts.
Is it just because it sounds cool, you think?
Yes. Maybe it's kind of like how, you know, how car companies like have like a flagship car that they never ship, like the Tesla Roadster, 2.0.
Yeah.
Like, I think it's kind of like that. If you like an investment fund, say they're investing in fusion, they sound really futuristic. That's maybe a bit facetious, but
No, I mean, we know that drives investor behavior. So like that's a big reason for what they're, a lot of the investment in AI today is being driven by this. So yeah, that's very interesting stuff. Where are you today with the company? Like, do you have a factory being built? Like, what's the current state?
Just to kind of give the whole overview, is 18 months ago, the company was just the two of us, me and Yasser. 7 months ago, we were in a WeWork with 10 people. Past 7 months, we built out the full-scale factory, pilot line, and the full-scale non-nuclear reactor prototype. Now we're 50 people. Looking forward, we are going to be starting construction on the first real plant in around 12 months. Which is pretty exciting. There's also a decent chance we can actually co-locate this nuclear plant with a data center there. So we're going to explore that over time. We'll see how that unfolds. In parallel, we're pursuing NRC approval for our first full-scale commercial plant. This is called the Aalo Pod, and that's going to be the product that gets deployed to power many, many gigawatts of data centers around the country. So I think it's pretty cool because, to go from incorporation to starting construction on a first real nuclear plant in basically 3 years, I think is somewhat unprecedented. So we're really proud of our speed, and that's super core to our thesis, is remaining a very fast-moving nuclear company. Oh, and one more thing I want to highlight is this kind of comes back to Ahmad's earlier question too about fundraising. Because we've done a good job so far of putting together a team that's done a lot of this stuff before, one of our main constraints as a company is just capital. The more money we can raise faster, the faster we can go here. And so we're actually thinking about maybe even bringing up the speed of our Series C, so doing the C, the Series A, the B all 1 year after another, and using that Series C to help start to do long lead time procurement on some of the gigafactory, which is going to be what a really high volume, high throughput factory can do. And if you do the work back on basically, the timing when we're going to have proven the first plant and when we're going to have the first commercial plant built, we want this factory to be ready to mass produce, possibly by the end of this decade aggressively. That's what might be able to happen. So we're trying to make sure we can walk and chew gum at the same time, like do all this stuff at the same time, prove the first plant, prove the non-nuclear prototype, raise to start long lead time procurement on the gigafactory, and lots more. So it's pretty hectic because there's a lot going on in parallel, but it's really exciting. I think it's going to be a pretty action-packed next couple of years.
I had one more question, and so that sounds very exciting. I'm wishing you all the best. By the way, if you ever need capital, Ahmad is ready to write checks. That's what I hear. 100 million.
I don't have 100 million sitting around. Yeah. If anyone listening has 100 million, send it to Matt.
Matt at aalo.com. All right.
Yes, exactly.
Last question from me. If everything goes well, you guys are both sci-fi guys, 20 years from now, where would you want to see, how would, Joe Schmoes like me, experience reality different, because of nuclear?
Oh my God. Yeah. Okay. So there's a pretty cool scenario here. Right now we're actually struggling, I think, as a species with, population decline. So let's assume that we can actually reverse that trend and keep growing and expanding. I think there's actually a world where we achieve 100 billion population on Earth while actually returning land back to nature and making better use of all the land we've already and resources we've already kind of laid claim to. So I'll give you a few examples. First of all, if you had a highly industrialized civilization with 100 billion people, if you tried to power that with solar, you'd be covering basically the whole Earth, all the land on Earth with solar panels. So that is crazy, and that helps to give the kind of explanation as to why we need nuclear. But another thought I had is I've been flying a lot for Aalo, probably 67 flights last year, I think it was. And when I was flying over the country, I was looking out and I was thinking, isn't it kind of weird how we're using so much land for farming? But I think this is kind of, a little bit crazy. And I think, farming is great. It's not really bad for the environment or anything. Well, except for methane emissions, but that's another story. But what if we did this push towards more vertical farming, more lab-grown meats, as long as we get the quality high enough, and return all that land to nature, and then make better use of our cities? Have you guys seen what they're doing in Saudi Arabia with Neom and the Line and things like that? So maybe making, cities like that are, entirely new cities powered by nuclear reactors in places that were formerly maybe even unlivable places, where you can kind of irrigate the land and terraform the land and make these new cities in places where it wasn't possible before, with higher kind of population densities that are just more well designed to make a higher quality of life. So I think there's some cool kind of vision around that could be possible one day if we do keep expanding. But the good news is that regardless, nuclear is just such a beautiful solution because it uses way less land, it improves air quality, and it can help us power anything from, our cities to, large industrial efforts like these data centers and so on.
Yeah, I'm in. I don't know how we convince people to have enough babies to get there, though. But, even if we get to 10 billion population, I think, I think it'll be powerful.
Well, the AI is going to take up so much energy anyways, right? Like AI is going to be actually probably more energy intensive than a human.
Well, actually, one of the interesting things is humans don't consume that much energy for the intelligence. And you could say the reason AI is so energy intensive per intelligence unit is that it's still kind of dumb. If you look at part of one thing that's happening with AI is it's getting much more energy efficient over time. I mean, we're still in this kind of exponential where we're spending more on chips and things like that. But the future isn't necessarily that these AIs are massive energy sucks. Obviously, it's more than we have now, but it doesn't mean it's 10x more necessarily.
Yeah, but even if you look at robotics and if you assume that there's going to be a lot more robotics and labor is going to be replaced by Waymos and all these things, so you're going to need probably a lot more energy for that future, even if the population declines by 30% or something. Don't you think?
Yeah, definitely a lot more than today, but I don't know if that's 10x more per. I mean, one thing is America and the Western world are still using quite a bit of energy per capita, but the rest of the world does not have as much energy. So just to get everyone up to at least this level or higher is a ton more energy required.
Yeah. Not to mention doing it in a clean way, right? So instead of doing, coal, which obviously causes major health problems, doing nuclear in a lot more places could be pretty great from a health perspective too.
I mean, there's a ton of other things that are enabled with extremely cheap energy, right? You can suck carbon dioxide out of the air. Obviously, you talked about terraforming, but a lot of the things that are limitations in the world are limitations because of lack of energy, not because of lack of science. So, I mean, ideally, we get spaceships that are nuclear powered. And that would be a massive enabler of space travel.
Yeah. Have you guys seen that commercial? I think it was don't quote me, but a Honda or Toyota commercial that kind of showed what if everything was gas powered, and it showed someone using a printer that was as a gas, putting out this kind of emissions in the office, or an electric toothbrush that's gas powered and it's got the smoke coming out. So it kind of shows how ridiculous it is that we do still have some things like that are putting out these, PM 2.5 particles that are causing millions of early deaths around the world today. And, I think there is just this future of everything being electrified. And I think there's a lot of reasons for that are pretty obvious. But then also another really cool one is desalination. So right now, the whole idea of manufacturing water more cheaply than we currently get it from certain, aquifers or places we do today, and especially in arid places like Texas, California, so on. This could actually be a pretty major market in the relatively near future. So, that's another one to look at as well.
Looking forward to the bright future, thanks to Matt and the Aalo team. Thanks for coming on, Matt. This was a fun chat.
Awesome. Thanks for having me.
Thanks, everyone, for listening. Please leave us a review on whatever channel you're listening on. Makes a big difference to the algorithm and to the success of the show. And see you all next week.